We're going to talk about two things. We're going to talk about arc length and sector area. All right, arc length. Arc length is super easy, but let me show you what it is before I show you how to find it. So if I've got this circle, it's a decent circle. Yeah, this is new. Remember, theta measures my angle. Wherever it happens to be, theta is my angle. The arc length is exactly what it sounds like. It would be the length of what we call the intercepted arc. Now, y'all should have learned that in geometry, but I'm going to say you might not have. Intercepted arc means it's where the angle intercepts the arc. Okay, so that little piece, this little purple piece, would be the arc length. So what we're doing is we're finding a portion of the circumference of the circle, essentially, is what we're doing. Okay, really easy. To find arc length, we use S to represent arc length, and it's radius times theta. But there's a little stipulation here. Your theta has to be in radians. So if it's not in radians, you convert it to radians, and then you multiply it by the radius, and you get the arc length. Easy peasy. Let me show you an example. Radius. You'll be given the radius, yes. Theta is the measure of the angle, right? They will give you theta. Measure of angle in radians. So I'll do one that's already in radians, and then I'll do one that's in degrees, so you can kind of see the difference there. I'll give you a second though. S is for arc length, yes. So the arc length is radius times theta. Both of these are just little formulas you just know. And ready? Let's say that my theta is 5 pi over 6, and my r is 3. And I want to know what the arc length is there. Now, first of all, how do I know that theta is in radians here and not degrees? The pi, which it doesn't have to have a pi, but the pi is a dead giveaway. If it does have a pi, it's probably in radians. But I could have pi degrees. But what do you notice is missing if it were degrees? The little degree sign, right? I could do this and I would know it's in degrees. Otherwise, it's in radians. Those are the only two ways we know to measure angles right now, degrees and radians. All right, so this is in radians, so I'm good to go. So how do I find the arc length here? S equals R times theta. Theta is already in radians, so I don't have to worry about converting it over. Now, what I'll have to do is I'll have to multiply and simplify to find out, let's see, I can divide them both by 3. So 5 pi over 2. So that means my length around whatever this theta is, 5 pi over 6. That means this length is 5 pi over 2. I just know where that is. You won't know it yet. You don't have to. You don't have to know any of this yet. No, I know. We're fixing to build a unit circle, and you'll know where these things are. Right now, all you need to know is this. Divided both of them by 3. Yeah. Let's do another one in radians. What if your theta is 2 pi and your radius is 6.2, and I'm going to give this some units. I'm going to say 6.2 yards. So if theta is 2 pi, and my radius is 6.2 yards. What is my arc length? So that's my S, right? What am I going to do? 2 pi times 6.2. What's 6.2 doubled? 12.4 pi. And I'm going to put the yards because they gave me the units there initially. So that means if my theta is 2 pi all the way around the circle, right, it measures 12.4 pi yards. Essentially, that's the circumference of the circle. Now, what if I'm not in degrees? Oh dear. I mean, what if I'm not in radians? I'm going to have to switch it. So what if my theta is 15 degrees and my radius is 8.4 meters? What is the arc length? Okay, so I got to do, the first thing I have to do, because it has to be in radians, right? 15 times, is it 180 over pi or pi over 180? Pi over 180. The units I'm looking for need to be in the top. So times pi over 180. And I'm going to simplify that. And you can use your calculator, 15 divided by 180, math, enter. Or you can keep going through if you know how to divide this and simplify it. What is it? Pi over 12. So my theta is really pi over 12. So now to find the arc length, pi over 12 times 8.4. I don't know what you get here. Do 8.4 divided by 12 and make it into a fraction. 7 what? Yes. 84 over 120. And then you can divide them both by 2. They did it on their calculator. You can do it on your calculator, but they said, how does it turn into that? Well, if you move a decimal over and top, move them both over. 84, so 12 goes into both of those. 84 divided by 12 is 7, and 120 divided by 12 is 10. Because you can't have a decimal and a fraction. But you can use your calculator. I'm not even making y'all do these by hand that way. Let's see if you really understand. An angle in a circle, theta. The angle is theta. The circle has a radius of 6 meters. And it has an intercepted arc length. So what's the variable for arc length? S of 10 meters. What's my theta? What? Tell me what you're doing. Remember, what's the equation for arc length? Radius times theta. I'm looking to find theta. You just plug it in. Yes, I have radius and I have S. So 10 equals 6 theta. You don't necessarily have to have one. It can still be in radians. So here's my answer in radians, because anytime I use this little formula, it's always radians. What if I asked you, and this is where it's going to get confusing, so you have to understand backwards and forwards of it. What is your angle measure in degrees? I'm going to multiply it by what? 180 over pi. It's going to give it to you in radians because that equation, just because it has a pi doesn't necessarily mean it's in radians. Okay, I can have radians without a pi. The answer it spits out is always going to be radians. So now if I want to convert it over to degrees, I multiply by 180 over pi. Okay, that's what we did Friday. So from degrees to radians, I do pi over 180. From radians to degrees, I do 180 over pi. So what is 5/3 times 180 over pi? So 300 over pi degrees. There's no pi in my radian this time. So radians don't have to have pi. They just, most of the time they do, but they don't have to have it. This is my degrees. Five times 180 and then divide by 3. Did that one confuse y'all? It's going to go with the unit circle that we'll do tomorrow. Yeah. Unit circle tomorrow. Yeah. All right, listen. You got to listen to this one carefully. Y'all, I need somebody to run to Miss Montgomery's office in just a minute and grab some. There's a bench in her office that's got some Reality Town booklets that I need. A bench? All right. A merry-go-round. The other one was a word problem too, I'd say. A merry-go-round rotates 2,808 degrees per ride. So it's continuously looping, right? 360, and then another 360, and then another. So a total of 2,808 degrees. How far, if a rider is seated 8 feet from the center? So what does that tell me? The radius, right? Here's my rider. From the center is 8 feet. So my radius is 8 feet. This, of course, is my theta. So I want to know, how far do you travel around if you ride that merry-go-round a complete cycle? So what am I looking for? Okay, so yes, I'm going to have to get to radians, but what am I looking for? The S, I'm looking for the arc length. I want to know what the total length around is all those times. So, feet. So S is, remember, R times theta. And I'm just plugging in what I know. Whatever I'm missing, I'll solve for, okay? Like the other one, I was missing what? Theta, and I solved for theta. This one, I need the arc length, but this needs to be in radians. How do I go from degrees to radians? Pi over 180. So on your calculator, 2808 divided by 180 gives you, give me a fraction, math enter. 78 over 5. So 78 pi over 5. Now all I have to do is plug that in. So S, okay, great. 180. No, do math enter. Yes, yes. These, it's better to be all in fractions with exact answers. All right, my radius is 8. My theta is 78 pi over 5. And what do I get? Feet. Now, if I wanted a decimal approximation for that, in other words, about how many feet did I rotate around? Tell me what that number would be. Yes, plug in the, divide the fraction and multiply by pi. This is the technique. Hey. They were supposed to go, she said to send a student that is on a bench in her office with the office reality cover. You're really only Oh, I see. I realized your question after a while. Okay. All I know is she said that they were. Okay. What you got? 30. 3. Always go 3. 392. So if you get on that particular merry-go-round and you start going around, you will have traveled approximately, this is the little approximately sign everybody always does, 392 feet. That's crazy. All right, does that make sense? They did this on their 624 divided by 5 and then multiplied by pi. I don't know. Because I had to round it. No, this is the exact answer. That's really what we want. That's what we're looking for. That's why I have to do approximately. That's why the fractions are always better than the decimals, because you have to truncate them around them, and it's not an exact mix. All right. Y'all ready to do area now? It's a little bit harder. Yeah. All right, so you know how whenever we're talking about circles, we talk about in geometry, we talk about circumference and we talk about area. Circumference is pi times diameter, area is pi r squared. These are very closely related to the sector, area, and lengths here. So area of a sector. So I needed to find a sector for you because I'm going to assume you don't remember that from geometry or you weren't taught that in geometry. So a sector. Y'all didn't get the circles? All right, so this is my arc, right? That's my intercepted arc. This is my sector area. Like a piece of pizza. Okay? Huh? All right. So I'm going to show you how to find the area of that piece of pizza or of that sector. That's right. 1/2 radius squared times theta. Notice it is very close to the area of a circle. Theta here, again, must be in radians. Right, Rhett? Now, my shaded area could be small or it could be large. I could be a whole more than, like this could, the purple could be my sector area or this could be my sector area. It just depends on where you put theta and how big theta gets. But any of those would work. All right, let me show you an example. It also doesn't have to be in your standard position here. It can be anywhere. Yeah. Miss McGee, try carrying it out the flight of stairs. Drop it to my side. There you go. Wow. All right. 4 centimeters, and then theta here is going to be 74 degrees. And I want you to find the area of that. Mark, set, go. That's in degrees. See the little degree symbol there? So, but yes, I need it to be in radians though. Yes. But you got to square it. All right, let's go. We'll do this one together and then I'll give you one on your own. So theta here is 74, but I can't be in degrees. I need to change it to radians. So how am I going to do that? Pi over 180. So tell me what my theta is. 37 pi over 90 radians. Is everybody okay? 74 divided by 180. And then math, enter. Both of them can be divided by 2. This is 74 over 1. 74 over 180. I could divide both of them by 2. So my area would be 1/2. What is the radius? 4, but I got to square the radius times theta. Yes.
Wait, is that 8?
Yes. Yes. 16, half of 16 is 8 times 37 pi over 90. 148 pi over 45. Centimeters squared. Nice, because it's area. Perfect. Okay. Because exponents come before multiplication in order of operations. This is on your calculator. Do 8 times 37 divided by 90, and then do math, enter to get a fraction. Word. All right. Let's do another. What's in that cup? It looks yellow. Oh. That's what it looked like. I was like, is he sipping like chicken broth?
One of the cups, I looked it up and the whole inside of the cup was yellow. I'm not using that one. I run my finger at it, it's yellow.
Find the area. 7 kilometers, 2 pi over 3 is your theta there. Mark, set, go. Not necessarily, but since there's no degree mark, then I know it's in radians. $19. This is the radius, this is the theta. I don't know how to word it, let me work. This one's a step less because my theta's already in radians, right? Okay. Yes.
Oh, I did something wrong. I crack it open. Hey, let's go. I got that right.
Good. The area of a sector of a circle. The area of a sector. 1/2.
I thought you would just do the 49 and then the half.
49 times a half is 49/2. I just did it without a calculator. No. All right, the area of a sector. Last one, y'all stay with me. The area of a sector with a central angle of 240 degrees is 134 square feet. What's the radius of the circle? Well, this time I'm telling you that the area is this. Theta is this. What's the radius?
You have to tell me. Yeah, I'm not good with words, bro.
Just plug in. Just plug in what you know. You know what the equation is, right? What's the equation for area? That's right, Hannah. What are we changing? The degrees to radians, the 240 over. So how do I do that? That's right. Pi over 180. What do you get? What's 24 over 18? 6 goes into both of them. 4 pi over 3. Plug in what you know. What do I have? I have the area. I don't have the radius. That's what I'm looking for. But I do have theta. What do I do to solve for r? I'm going to go ahead and multiply these two first. Some of y'all might have gone ahead and flipped and multiplied. I'm going to combine and kind of clean up one side first so that I have r squared times, if I multiply 1/2 times 4 pi over 3, I will get 2 pi over 3. 4 pi over 6, which is 2 pi over 3. Okay? Now I'm going to flip it. So the 1/2 and the 4 pi over 3 I multiplied together over here on the side to clean it up. That's right. Say that again. That's okay. That's the same thing as multiplying by 2. Yeah. That's okay. You'll come back to the same thing. You just got an extra step on us. Yeah. How do I get rid of a fraction that's being multiplied? I multiply by the reciprocal. So I flipped it. Okay, everybody stop. Where are we? Where am I losing you? Oh, I'm sorry. I'm sorry. That's okay. You multiply by 3/4 pi, and then you multiply by 2. That's fine. I flipped that fraction over so I could get rid of it. All right. 3/2 pi times 1/34 is what? What is it? What? I would leave it just like that. Unless you need to get a decimal approximation, I would just leave it like that. It doesn't make sense to take the plus or minus on this one because you can't have a negative radius, right? So we're just going to take the primary root anyway, so I would just leave it there.